The Poultry House Leakage Area Calculator, contained within the Poultry411 app, provides a producer a lot of information about what a static pressure test result really means. For decades, we've been closing up poultry houses, turning on a tunnel fan and measuring the pressure. Obviously, the higher the pressure, the tighter the house. But what does a 0.10 mean versus like a 0.20 in terms of what it really means to the producer? So to use the app, you click on Poultry House Leakage Area Calculator. A message comes up saying that you generally should use about 1 CFM per square foot of floor space in fan capacity when conducting the pressure test. So 20,000 square foot house, we're looking for somewhere around 20,000 CFM fan. Could be 15, could be 25, could be 27, but we're looking for something in that ballpark. So let's close that out. Put in our house length, it's 500 feet, it's 50 foot wide. And let's say our test fan moves 26,000 CFM. Let's say it's a 54-inch fan. We looked at Best Labs at about a 0.1, it moves 26,000 CFM. We put in our static pressure that we found when we did our pressure test. Let's say it's a 0.07. We're done. We calculate. First thing it tells us is how much leakage area we have. There's 25.1 square feet of leakage area somewhere in that house. It also gives us a relative leakage area, how many square feet of leakage there is for every 1,000 square feet of floor space, so we can compare test results from different sizes houses using different size fans. Here, a 1.01 reading, if we look to the right, sort of get a scale, it's basically very poor. But what does that mean, very poor? So we can actually continue on with some more calculations. And let's look at the 24-hour heating cost estimate. So for that house, what would happen if the inside temperature was 85 degrees? Let's say we're brooding or towards the end of the brooding. Outside temperature was 32 degrees and there was an 8-mile-an-hour wind blowing. How much additional fuel would we have to use to heat up all the air coming through those cracks? We hit calculate, and we learn about 78 gallons per day. On that cold, windy day, would be required to heat all the air coming through the cracks. Now that's in addition to what the fans are bringing in. But this is extra air that's coming in through the cracks on that windy, cold day that we're going to have to heat up. That's going to increase our heating costs. So let's just go back. Let's change back a little bit more. Let's change our house tightness to a 0.25. Let's say it's a very tight house. We hit calculate. Our leakage area dropped to 9 square feet. Our rating has gone up to only 0.37 square feet leakage for every 1,000 square feet of floor space. We're above excellent. We go 24-hour heating cost estimate associated with our cracks. We put in 85 degrees. The outside temperature is 32 degrees. Our wind speed is 8 miles per hour. Calculate. Now what happened? We're down to 28 gallons of propane is going to be required to heat the air coming through the cracks. We've gone from almost 80 down to 28. You can try for different wind speeds, different temperatures, just to give you an idea of how much your cracks are essentially costing you. Now we can go back, and now we can check. Well, let's go all the way back and change our pressure to back what it was before, 0.07, very loose house. Again, we hit calculate. Now we're going to use our inlet system effectiveness calculator that's associated with this. Again, 25 square feet of leakage, very high leakage area. And what we're going to say is that we're going to use a couple 36s for minimum ventilation. Let's say they move 20,000 CFM in total. Let's say there's 30 inlets in our brooding area. We're in half house brooding, running two 36-inch fans. Those inlets can open at 11 inches. And they're 42 inches wide. We're not going to, it will tell us how much they need to open using this app. We're just putting in what their maximum opening is. Hit calculate. And we find out that we only need 1.5 square feet of inlet opening because we have so much crack area in the sidewalls and in the end walls. The inlets are only going to open up 0.2 inches, and a very low percentage of air will enter through our inlets. So we're not going to be very effective. We're basically crack ventilating. We go back. We go back. Let's change our pressure to a 0.25. Done. Calculate. Again, very tight house, excellent rating. How will our inlet system work? Hit that. Again, we put in the same information, 20,000 CFM. We're using two 36-inch fans. There's 30 of them. Maximum open is 11 inches, 42 inches long. We hit calculate. And now we have to provide much more opening using our inlets because we've got rid of the cracks. The inlets are going to open now 2 inches, so we're going to get a decent inlet opening. We should get good throw of air across the ceiling. And now 66% of our fresh air will be coming through our inlets. So 66% of that air we bring in will be moving along the ceiling. It will be mixing with the warm air next to the ceiling, heating up and drying out before it moves down to floor level. So again, this app provides the user really some meaning to what those static pressure tests mean, both in terms of how effective our inlets will be in ventilating the house and how getting that house tight will lower our heating costs. We hope you enjoy the app, and if you have any questions, please let us know.